Thank you very much indeed for your kind introduction, and thank you for all of you for coming today and for this opportunity for us to participate in this Wiley author workshop. As you can see, our title is Strategy and Steps in Writing Research Articles for International Submission. Patrick and I have been working together for 14 years or so, developing a methodology where the language and the science can work together to develop skills for publishing effectively in the international journals. In brief, our method suggests that you should use your existing research skills on the problem of getting articles published. You are already researchers. You already have skills in research. So our suggestion to you is that you should analyze successful articles in your own field and analyze the journals that they come from in order to learn how you can reverse engineer your own articles so that they will meet the requirements of the journal. But you need an analysis framework. So our suggestion is that you can use the results from applied linguistics research. You've probably never heard of applied linguistics, but people in this field work long and hard to analyze successful documents and to draw out principles that you can follow in writing your own articles. This is the title of the book again, as was introduced to you earlier, and this is the website for the book. Now, unfortunately, the text of the book is not on the website, but many other useful and interesting things are on the website, so I suggest that you have a look. As well as learning from the book the strategies from applied linguistics for analyzing successful articles, we recommend that you need to learn strategies for playing the publishing game. It's a game we are all involved in. The more we can look at this as like a board game and not like something that damages us when we are rejected, the more we can use it as a kind of business decision, our steps in writing and revising our articles, the more successful and the more happy we will be. This is the basis of the analysis that we do. For any communication event that you are ever involved in, these four aspects enable you to analyze the event in order to use it, to do it successfully. So the first one is audience. Who is the audience? What do they already know? What are they interested in? What do they want from you? How can you attract their attention? Number two, what is your purpose for this communication event? Students often say to me, for a paper, my purpose is to share my results with my colleagues. But usually there are other purposes as well. You want to get a postdoc in a good university. You want to build a network with other researchers. You want to build your career. All of these are part of your purposes. Number three is format. For an article, the format is fairly set by the journal. Yes? These rigid formats have constraints. We must fit inside. But they also have very powerful opportunities. And we should learn to take advantage of the opportunities of the format. So we must study, look at the differences between the different formats and how they relate to the last one here, which is assessment. because that is the fourth component of the communication matrix. Who will assess you? How will they assess you? As much detail as you can possibly find about assessment. All of this is useful for writers of articles. So this is the process that we suggest in the book for producing a draft. Begin with your results. Your results, your findings, drive the study. Everything in the paper must relate to the findings, the results that you report. First, think about figures and tables. Think about the visual representation of your results. And then the sentences. That's the very first step. Then you are in a good position to choose your target journal, to choose the journal where you will send the article, because you can match the story of your results with what the journal asks for. Methods comes next in the book, but it can be written earlier or later, but it is good to write it after the results because you know which methods to include. Then, importantly, the first draft of your introduction. You don't have to finish it now. It's good not to finish it now, but dot points, bullet points for your introduction. That will be the main focus of my part of the talk, and I will look at an example in detail in a few moments. Next comes discussion, because discussion and introduction relate to each other closely. The next step is to revise the introduction so that it matches the final story that you decided when you were writing the discussion. Very often we have a good idea when we are writing this discussion, and maybe our big story changes a little. So our introduction needs to be changed to match that final story. Does that make sense? Dong boudon. No? Yeah? Okay. Okay. And the last thing, of course, is the abstract and the final title. The thing that is different about this order from many books of advice is that we do not suggest that you begin with the introduction. Because until you are clear about the results, you don't know what you are introducing. Yeah? Now it is important to think about the relationship between those parts of the article and the requirements of the gatekeeper. In China, I never have to explain what is a gatekeeper, because every gate in China has a gatekeeper. So, for your journal article, the gatekeeper is the editor and the reviewers of the journal. They're the ones who decide whether your article will be published, will be sent to review, and whether it will be published. So they are your first audience, and I think a very important audience. So we need to think about how the structure of the article relates to what the editor and the reviewers want to publish. We have in the book a collated referee report form. So these questions have been gathered from many different journals and put together. These questions are very similar from journal to journal. And so we have made a combined list here to make it easy for people across many fields of science to see what are reviewers looking for. So quickly, is the contribution new? Is the contribution significant? Is it suitable for publication in the journal with a capital J? That means this journal, the one you sent it to. Have you chosen your target journal effectively? Next, do the methods and the treatment of results conform to acceptable scientific standards? Are all the conclusions firmly based in the data presented, in the paper, not in your thesis on the shelf, but in the paper? Then these are more detailed, more nitty-gritty, we say, but they are in the minds of the reviewers as they read your draft. Is the organisation acceptable? The right information in the right parts? Is the length of the article satisfactory? Are all the illustrations, the photographs, the tables and the figures necessary? And are the captions adequate? Adequate. You have to check the target journal because every one looks different. Do the title and the abstract indicate the content of the paper accurately? Are the references up to date, complete, and correctly abbreviated? And then finally, a judgment overall of quality. Sometimes numerical, sometimes in a word. What is the referee's recommendation? So that is the general list that we have published in the book. I went online and had a look at the criteria for advanced materials, advanced functional materials, and small, the cluster of journals that we are focusing on today. And that is what they say. This is what the referees are asked to focus particularly on. How important are the results? So, new and significant. Does the data obtained by experiment or calculation verify the hypothesis and conclusions? Is the length of the manuscript appropriate for its content? And the general summary of value at the end, should the article be accepted? Yeah? Now, let's think about where in the manuscript do you think a referee or a reviewer would look for the evidence they need to answer those questions? Because the structure of articles means that readers can jump around. They know what they expect where. So we must give them what they want, where they want it. We're going to think now about the top three, the ones that really determine the success of the paper. Is the contribution new? Is it significant? And is it suitable for publication in this journal? Now, if this were a workshop and we had time for discussion, I would ask you to talk about this and to report back to me. But sadly, we don't have time to do that now. So think about it. Where in the manuscript do you think the referee would expect to find information about new, significant, and suitable? Now, I will tell you that the results of considerable amount of research indicate that the introduction is the place where these three, the information, the evidence for these three is largely located. This is the only time you will see this picture in this presentation today. So I'll take a moment to talk about it. Have you seen this shape before for an article? Yes? Anybody else? No? Have you seen this shape before? No? Not very many. Okay, We like to draw an article in this shape for this reason. The little box at the top is the abstract. And now we have the introduction. See the shape? It starts broader. That is for the broad problem in the field that is being addressed. But then it narrows down the shape. By the end of the introduction, we're just focusing on what this paper did. Then, what you did, what you found, and then the discussion, which is the mirror image of the introduction. The discussion begins with what you found. And then it broadens out. It compares with other people's work. It speculates. It explains. And by the end of the discussion, you are talking about the same problem that you spoke about at the beginning of the introduction to show what contribution does your work make to this problem. Yeah? That's why we draw this sand clock picture. Okay, so the introduction is important for showing that your work is both new and significant. It's quite easy to show that work is new. The challenge is to show that it is also significant. The applied linguists have done a lot of work looking at introductions to scientific articles. What we present here is a pared back, a simplified version of the stages of argumentation in a scientific article introduction. We use this set because we've shown that it is relatively easy for scientists to work with this set to construct their own introductions. So we need to look at the 6 steps, and then I will apply them to an introduction in nanoscience and technology so that you can see how they work in practice. Please pay attention to the colors of the text because the text colors will reappear on the following slides. So, before I begin, the names of the stages are numbers. But don't be confused. That does not mean that 1 always comes first and 2 always comes next, all the way down the list. These stages can recur. We can have 1, 2, 3, 1, 2, 3. We can have 5 anywhere. Yeah? These are the names of the stages. So stage 1, statements about the field of research, providing the reader with a setting or a context for the problem to be reported in the paper, and claiming that it is important and in the center of our concern. Stage 2 in red type, more specific statements now about the aspects of this problem already studied by other researchers, with the goal of laying a foundation of information already known. Yeah? Stage 3 in blue type. These are statements that indicate a need for more investigation, a gap, a research niche, a need for extension of the work. Yeah? Then, in green type, we have stage 4, and these statements appear in 3 different forms. You can find out which kind by looking in your target journal. Either stage 4 looks like a purpose or objective. Therefore, the aim of this study was to do something. Or it can be the main activity of the study. Here we present, this study investigates, or in some fields and some journals, there is a summary of findings or results at the end of the introduction. Not all, but in some fields and some journals, it's a requirement. Then stage 5 in purple type. These are optional, the stage 5s, but I think they are becoming more common as publishing becomes so competitive. These are statements that give a value or a benefit for carrying out the study. Then we have stage 6 in this sort of maroon colour down here. This is a map of the rest of the article. Now this is very, very specific to some fields. Yeah? I think maybe not yours. Yeah? But in some fields it is common to find a map that says, and section 2 will do this, and section 3 will do this. Yeah? So that is stage 6. So can you remember the colours? Because now we're going to look at an example. But before we do, I'm going to talk about the process that we suggest in the book for writing your introduction. We suggest, remember you've already got your results story clear because you started with your results. So now you can write the stage 4 of your article first. Your objective, your main activity, or your findings summary. You write the stage 4 first. And it's very important that you include in it all the elements of your story that make your work new and significant. Then, blue type, what stage was that? 3? Stage 3 is the gap. So you write your stage 4 first, then your stage 3. What is the gap that you will address? Then think about stage 1. How will you attract the attention of your editor and reviewers? Then you need to arrange the information you've collected from the literature into stage 1, 2, 3 chunks, which justify each element of your stage 4. Then you think about, do I need a stage 5 in my introduction? Do I need a value or benefit? If yes, where should I put it? And then we combine the pieces so that the introduction flows. Now we're going to look at an example from Advanced Functional Materials. Now this method that we use is descriptive, not prescriptive. So we don't say, you must write your introduction like this. We say, we can see these stages in the introductions of successful papers. But you here today might have a different idea from me about the function of the sentences we look at. And if you do, I am very happy because you are starting to think about function of sentences. That's great. So, this is the serious stuff. I hope the people on the side can see this well enough. Maybe you can listen to me read. I hope I don't make too many mistakes in the pronunciation of the technical terms. Remember, I'm not a scientist, I'm an applied linguist. So I apologize in advance. So the title, Highly Conductive and Transparent P.PSS Films with a fluorosurfactant for stretchable and flexible transparent electrodes. Published last year in Advanced Functional Materials. Now remember, green type, stage 4, either objective, main activity, or findings summary. Purple, stage 5, value or benefit. See if you agree as I read the sentences with my analysis. This is the last paragraph of the introduction. In this work, we report P.PSS films with a record RS of this number of things. You see, it doesn't matter to me what they are. It matters to you, yeah? But this is the important finding, yeah, that is being summarized here. The conductivity of the film was improved using a combination of DMSO and the fluorosurfactant zonal FS300. In addition, the fluorosurfactant improved the wetting properties of the solution. Now, I think all of that is findings summary. Do you agree? Yeah? Okay. Except for record, and that's the achievement, yeah? The benefit, value. Now, some more, stage 5, which enabled the facile deposition of highly conducting films on a variety of hydrophobic substrates that would otherwise not be possible. Is that value benefit? Yes? So that's stage 5. Back to stage 4. These films were shown to be both stretchable and flexible when deposited on a buckled PDMS substrate. More results. Now the last bit, if I could do green and purple together, I would, because it's a mixture, and capable of replacing ITO as the anode in devices such as organic photovoltaics. Okay? So that's our stage 4 and 5. Now, if the scientist wrote that first, and his task now was to justify all those bits, let's have a look at how they did it. We haven't got time to look at the whole analysis because it's a long introduction, but my whole analysis will be on the website, on the Wiley website. So, the author task after stage 4 is to write 1, 2, 3 paragraphs to convince the reviewer that each one of those stages is new and significant. Here's the first paragraph. Remember, black is stage 1, context, claiming importance. Blue is stage 3, gap, need for extension. Red is stage 2, work already done by other researchers. Okay, let's have a look. Next generation optoelectronic devices, such as solar cells, electronic paper, touch screens, and displays, based on conjugated polymers, small molecules, colloidal semiconductors, and carbon allotropes, require materials and processing techniques that are low cost and compatible with deposition over large areas on plastic substrates. Claiming importance. Yeah? The usefulness of these materials would be broadened by the ability to accommodate bending and tensile strength, flexibility and stretchability, which not only make them amenable to devices that require mechanical compliance, but also more durable. Need for extension. Yes? Would be broadened. Usefulness would be broadened. Would always means if. Yeah? If we could do this, yeah, they would be broadened. Back to stage 1. Solar cells and displays require at least one electrode material that must additionally be both highly conductive and transparent. Back to stage 1, introducing a new bit. Now, I'm not sure whether this is 1 or 2, maybe 1/2, a mixture of background, importance, and other people's work. Currently, indium tin oxide, ITO, is the material used as this transparent electrode. Due to its excellent optoelectronic properties with a sheet resistance on the order of this big. Okay? Now, what's blue? What stage? Gap, stage 3. However, there's our signal word. Yeah, it tells us we're moving into a gap. Students tell me, but I use however too much. No, you don't. Yeah? However, ITO suffers from two major drawbacks that render it a non-ideal choice as a TE for next-generation devices. One, the increasing price and scarcity of indium, which makes it difficult for its use in low-cost, large-area electronics. And two, the brittleness of ITO films, which render them unsuitable for applications that require stretchability or flexibility. Remember, in the stage 4, we had flexibility and stretchability as a claim. Yeah? Here's the need. There are several emerging materials. What color is this? Black, back to stage 1. Yeah? There are several emerging materials that have shown promise for the replacement of ITO films that have the potential for large area coverage and some degree of mechanical compliance. Graphene, metallic nanowires, these materials include carbon nanotubes, graphene, metallic nanowires, and conducting polymers. Now, that's as far as we go today. What is going to come next? What's going to happen in the next paragraph? I think we're going to talk about carbon nanotubes. Do you agree? We're going to get advantages, we're going to get a however and a disadvantage. Yeah? All the way through. So, here is our stage 4 again. And these circled bits indicate the parts of the stage 4 already covered, already justified in the introduction. So the rest of the introduction has to cover the rest of them. Yeah? See the process? Does that sound logical? You think you could do that? Maybe? Okay. Now that's as far as we've got time to go with that part of it. So now I'm going to hand over to my colleague Patrick O'Connor to talk about some strategies for playing the publishing game.
Hello, very nice to be here. Please, before I start, please tell me who has published a scientific article. Put up your hand. Who's published? Okay. Put your hand down if you have never been rejected by a journal. Huh? Okay. I think if you have, so good, you're in the club, right? If you have been rejected, if you have never been rejected as a scientist from a journal, you're probably not trying hard enough. Right? The natural state of a scientist trying to publish is dealing all the time with rejection. Yeah? And if not rejection, dealing with difficult reviewer comments. Yeah? And even sometimes the editor will write to us very unclearly. We are not sure if the paper should be changed, which things absolutely should be changed. Sometimes, last week I was in Qinghai and I looked at the reviewer comments for several papers to students. It was unclear if the paper was accepted or rejected. It's not even clear. So editors have a lot to be responsible for, but I want to just go through a little bit of understanding of the editor and reviewer and how to deal with that. Okay, the book is more expansive, but I will just begin a little. So we conducted a study of the correspondence surrounding acceptance of papers. Yeah. So who has seen the rejection letter of their supervisor? Anyone? Does your supervisor show you their rejection letter? Usually not, right? Scientists are too embarrassed about that. But remember, rejection is a sign of success. The more you publish, the more you will be rejected. Really. Because as you progress in your careers, you will become more confident. You will try to tell stories that are a little bit above the evidence. You will try to stretch the meaning of your data a little further. You will try to put a little less data into each paper and publish more papers. So you will face rejection throughout your career. The evidence is that the most successful publishers are rejected more than unsuccessful publishers. Okay? So I want you to start thinking rejection's not bad. Not so bad. Of course, at the start of your career, it can be very crushing. It's like when a girl or boy says no to you when you ask them to dance. What? I thought I was going to be successful here. And it can set you back, but you have to be courageous with that. So what the study we did does is tries to come to some evidence about the successful strategies used by authors in dealing with the editor's comments and the reviewer's comments, right? So you should go back today to your supervisor and ask them, can I see the reviewer's comments from the last paper you had submitted? And look at that and think about what the reviewer was saying. Because when you can put the hat of the reviewer on your head, you will be a much better writer and publisher, right? Because the reviewer is given the task of understanding your work as well as you, but finding the gaps in your research. So when you can put their hat on your head, you will understand your research and the way you communicate your research much better. Okay. So we looked at the correspondence between editors and authors and reviewers from about 200 manuscripts from several international journals, and also asked some colleagues to give me some of their best material. Okay, because most people never see this. You only see it for your own work. So I thought, let's look at what happens across a large range of articles. And from that information, we categorized the reviewer comment types and the author response strategies for successful approaches. In the book, we go through a lot of information about what the types of comment are and what the responses are. Here are the 7 types of response. I did not find any comment from reviewers or referees that was not covered by this classification. Okay, 7. We'll just go through them briefly. The aims of the study are not clear. Yeah? Where do you explain the aim of the study? Introduction. What stage? 4. In green, right? What Margaret just showed you. Here is the aim of the study, explained. Did you notice that when Margaret showed you this, there is no gap? All of the introductions of all of the papers that I read are covered by the 6 stages that Margaret outlined. So if you can read journal articles in your field looking for these elements, these stages, you will become a much more effective writer. So the aim of the study is not clear. You will know to go to the introduction and fix your stage 4, right? If that's the comment. I'll go through the others a little quickly and show you one example. The theoretical premise, the theory or the school of thought, maybe some people think this, others think differently. Maybe you are in one group, others are in a different group, and you will be criticized because the reviewer thinks differently than you. So that sometimes happens. In my field, in ecology, it's very common. A lot of things are theoretical, evidence is scarce, you will be criticized for taking one perspective. The experimental design or analysis methods are challenged, right? It's a simple one, but it's very common to have somebody ask questions about your method. Maybe you're asked to supply additional data or information that would improve the paper. I've had that many times. The referee always thinks you should do a bigger study. Why not? The referee is looking at the great knowledge gap ahead and thinks your study could be improved with a little extra. But it is often difficult to do the extra. So you don't want to do that. But you will be asked sometimes. Maybe you will be asked to remove introduction or discussion. When you are beginning your writing, people often write too little or, in fact, too much in the discussion or the introduction, trying to explain themselves with more instead of with less. So it's common. Maybe you will also provide too much data. You know, when you do a scientific study, the data is like your baby. You don't want to take the arm or leg from your baby. It's yours. You love it, right? You want it all to go in that paper. Yeah? But you have to learn, as Margaret said, by saying, first, what is my evidence? What is my data? And what story will I tell? And then, that story, you will include only the data and evidence necessary for that story. And then you will start constructing, as Margaret said, in stages, the introduction to tell that story. Right? You may also be told that your conclusions are considered incorrect, weak, or too strong. Yeah? Many of the papers I look at in the institutes that I go to, particularly in my field, in China but elsewhere, people try to make a claim from a small study here for global climate change. Now, everybody wants to publish about climate change, and they have a small data set about one plant. So you will always be asked in that case to justify your conclusions. In the book, we explain how you use the language, the modal verbs, and the strength of argument to make the claims appropriate and strong enough to be supported by your data. Right? We also there talk about using the greatest data set in the world. You know the best data set for your study? What do you think the best data set in the world is for your study? The published papers is a massive data set that explains that your research will be built on the work of others, and your work will be explained in context to the work of others. So the great data set in your paper is not your data set, it is the literature that you cite. It has much more breadth and depth than your own study. Your own study adds to it by being new and significant and therefore important. But it is built on the greater knowledge. Okay? So that's important to understand. The referee may also say the study is poorly designed, poorly written, badly organised, or the English needs to be checked. Right? It's common. So these are the 7 things. So in the book we explain how can you deal with these kinds of comments by looking at how authors did deal with these types of comments. Here's one example. Just for the first one, the aim of the study was not clear. What can you do? You can check the aims are clearly stated in the introduction, stage 4, and rewrite that section to make it very clear. You can check the aims are consistent with the experimental design. Check for the match between the data you present and the method and your objectives. You can check that the discussion refers back to stage 4 in the introduction. So where Margaret showed you the matching relationships, you want to join the introduction to the discussion with the results. So you look in these places. When you write back to the reviewer, this is fairly simple stuff, but I see a lot of reviewers who don't do this, and therefore a lot of students don't understand. The best way to write to the reviewer and the editor is to show them exactly what you have done. So you make a heading of referee 1, and then copy all the comments one by one, perhaps in italic type, and underneath each one you say what you have done in response to that comment from the reviewer and quote the change in the text or the line or the table or the figure and the line number in the revised version. If you have not followed the referee's suggestion or their advice, in some case, you must give your reasons. But I can only encourage you, it is not a good time to start to argue with the editor if your paper is almost accepted. Don't start arguments. The reviewer's best friend, the editor's best friend is the reviewer. Reviewers are difficult to find, right, editors? It's busy work for people, usually unpaid. Who is a reviewer? Tell me, what does a reviewer look like? Like you? Like me? Yeah? Like all of us. Busy with other work, with children, with a partner, husband, wife, who's also busy, maybe wants to play sport, travels a long way to work. They don't have time to take arguments from you about your problems. But I say that, but I also want you to develop your voice as a scientist. So when the only time you should be thinking about arguing with the reviewer is when it is important for the story of your paper. And in that way, you will develop your individual voice as a researcher. So you will project into the world your ideas in your way. But you should not be silly about that and make arguments when it's unnecessary. Editors hate that. Yeah? Okay. Then, when you've done all of these things and shown the editor everything, you do it again for the next reviewer and the next. And you can also use a table to do that. You should put the comments in one column and the response in the next. Right? When I review a paper, I try to make the comments in such a way that the author will be able to respond to my comments in this way easily, so that the editor will have an easy job to match the response to the comment. Okay. I think I won't go further because we don't want to go for more time. We're going to have some questions. Is that right, Thomas? Oh, no, sorry. Oh, my apologies. So I will just conclude there, but with encouragement for you to go back to your introductions and look at what Margaret has said. I also encourage you to read. Read and read. Yeah? Sometimes your supervisor says, go to the laboratory and do another experiment. Go again, stay late. But you should read. You must find the time to read. The best papers are written by people who understand the field and the previous literature. Okay. Thank you.